Today we're going to focus on two basic concepts. The first is the formula weight or formula mass, and the second is the concept of the mole. And as we do that, I'm going to go through several examples and also work several problems so that you get this completely embedded in your head, because it's a very important concept now and it will be very critical. And I've actually included this in the basic science class now because it's become so important that I want you to have been exposed to it before you actually go on to chemistry class. And so let's look at how we go about calculating a formula mass. So the formula mass is the sum of the average atomic masses of all the atoms in a substance or in a compound as represented by the substance's formula. So let's look at the first example here. Here is a compound that has the formula of CHCl3, and as the slide says here, this is a compound known as chloroform. Now the formula tells you that it has one atom of carbon, one atom of hydrogen, and 3 atoms of chlorine. And if you look at the table, the way you calculate the formula mass is you take the average atomic mass of carbon times 1, so 12.01, plus the average atomic mass of hydrogen times 1, plus 3 times the average atomic mass of chlorine. Now, where do you get the average atomic mass? Well, you get that from the periodic table for each of these elements. And so if you add all that up, the molecular mass or the formula mass, it can go by several different names, is 119.37 AMU, atomic mass units. Now let's look at another example. Here is a compound, which again the slide tells you that this is aspirin, and aspirin's formula is C9H8O4, and so it has 9 atoms of carbon, 8 atoms of hydrogen, and 4 atoms of oxygen. And so to calculate the formula mass, you would take 9 times 12.01 plus 8 times 1.008 times 4 times, plus 4 times 16. And if you add all that up, you get 180.15. So the molecular mass or formula mass for aspirin is 180.15. So why don't you, here's the formula for ibuprofen or Motrin, and why don't you stop the tape at this point and on a piece of paper see if you can figure out what the formula mass or the molecular mass is. And I'll tell you that carbon is 12.01 AMU, hydrogen is 1.008 AMU, and oxygen is 16 AMU. So stop the tape at this point and see what you get. Okay, here's the table that shows how you calculate that. 13 times 12.01 is 156.13. 18 times 1.008 is 18.114. And 2 times 16 is 32. And then you add those 3 up and you get 206.27 AMU. Salt, table salt, has the formula of NaCl. And what you can see here is you take 1 times the atomic mass of sodium, 22.99, and 1 times the atomic mass of chlorine, which is 35.45. Add those two together and you get 58.44 for the formula weight of sodium chloride. Let's do one more. stop the tape and see if you can figure out what the formula mass or molecular mass for aluminum sulfate is. And you can see that aluminum sulfate's formula is Al2SO4, and the SO4 polyatomic ion is multiplied by 3. Now here is how that would be calculated, and see if you got it right. First of all, if you look up on your periodic table, you'll find that aluminum has an average atomic mass of 26.98. You take 2 times that, or 53.96. Then you look up and you find that sulfur, which is underneath oxygen, has an atomic mass of 32.06, and you multiply that by 3 and you get 96.18. Now, why do you multiply that by 3? Well, it's inside the parentheses, and so you have to take 3 times the sulfur, and you get 96.18. And then the oxygen, it's 3 times 4, or 12 times the AMU for oxygen, or 12 times 16, which is 192. And you add all that up and you get 342.14. So let's do some more practice. This time I'm gonna do it on a piece of paper to show you how you do it. So here's the first one. This is K2Cr2O7. K2Cr2O7 is the formula for potassium permanganate, not potassium permanganate, potassium dichromate. And let me open this up and we can take a look at how we would do that. Now, first of all, you take potassium, there's going to be 2 of those, and it's 2 times 39. Now, I don't have a periodic table in front of me, so I'm going to do the best I can to remember what each of these is. And I think potassium is about 39, so this is going to be 78, plus chromium, which I think is 55. I'm not certain about that, but I think it's 55. And you take 2 of those, and so that's 110. And oxygen, which is 16, we already did that before. 7 times 6 is 42, and that's 112. And so the molecular mass of this is going to be 300 AMU. Let's look at, here's glucose, which is C6, so that's going to be 6 times 12.01. I remember that from what we just did. H12, so that's going to be 12 times 1.008. And O6, which is going to be 6 times 16. This is 96. This is going to be 72.06. And this is going to be, let's see, 12, 16, 1. No. Okay, so that's going to be 6, 5, 0 point, and that's 10 is 1, 180.056. Barium sulfate, I'm not going to do. I'm going to let you do that because I don't remember what the atomic mass of barium is. Calcium acetate, it's got 1 calcium, and so that's 1 times 40. It's got 2 times 2 or 4 carbons, so that's 12.01 again. So this is 40. This is going to be 48.04. This is 2 times 3 or 6 hydrogens. So that's 1.008. So that's going to be 6.048. And then lastly, 4 oxygens times 16, that's going to be 64. So we add all that up, we've got 8, 8, 0, and then we've got 4, 10, 18, and 158.088 AMU. And this last one, which I've got kind of hidden there, which is acetaminophen or Tylenol, there's the formula. I want you to work that out on your own, and if you have trouble working that out, let me know, and we'll do that in class. Okay, the second concept I want to do or talk about is the concept of the mole. Now, first of all, we have to figure out what a mole is. Well, a mole is like a term like a dozen, or a pair, or a gross, or a ream. Those are all terms that signify a specific number of things. If I tell you I give you a dozen eggs, that tells you that I've just given you how many eggs? 12 eggs. If I've given you a pair of shoes, I've given you 2 shoes. If I've given you a gross of pencils, you may not know this, but a gross is 144, 12 times 12. And the term ream, R-E-A-M, is used in terms of paper, and it means 500 sheets of paper. Well, in chemistry, the mole is like those previous terms. And a mole has been found to equal 6.02 times 10 to the 23rd molecules of anything. So 1 mole is equal to that number of molecules. And that number is also known as Avogadro's number. Now what you see in the picture here is the mass of a mole of these various substances. So a mole of zinc has a mass of 65.4 grams. A mole of carbon has a mass of 12 grams. A mole of magnesium has the mass of 24.3 grams. A mole of copper, 63.5 grams, and so forth. Now the mole, as I said, is the amount of substance that's equal to the formula mass in grams. You may have noticed, for example, carbon there, 12 grams. Well, if you look it up on the periodic table, 1 carbon atom has a mass of 12 AMU. And if you pull out your periodic table now and look at all of these various substances, you'll find that each of these masses in grams represents the mass of a single atom in AMU. So the molar mass, so the mass of the mole of any particular substance is equal to its mass on the periodic table expressed in grams. And as it turns out, it's also true the molar mass of any compound. We've just gone through over 10 minutes looking at how to get a formula mass for various compounds. Well, as it turns out, the molar mass of any compound is equal to that substance's formula mass expressed in grams. That's called the molar mass. So each sample contains 6.02 times 10 to the 23rd atoms, or 1 mole of atoms. Just like 1 dozen atoms would be 12, and 1 pair of atoms would be 2, 1 mole of atoms is always 6.02 times 10 to the 23rd atoms. And as it turns out, whatever the mass is on the periodic table, that's the mass in grams, the molar mass, for that substance. And if you figure out the formula mass by doing the calculation as we did in our previous several slides, you also find the molar mass for any compound. Now at this point we will stop And as we go to the second part of this discussion, we will continue to talk about the mole, and we will do several calculations using the mole.